Hello students, welcome to online lecture series of Discrete Mathematics. So now for today's lecture, we'll see what is the propositions and what are the different laws of the logics, or you can say what are the different identities law. So a proposition or a statement or a logical sentence is a declarative sentence which is either true or false. Or you can say any sentence that contain a value is either true or false. This is nothing but the proposition. For example, Jawaharlal Nehru is the first Prime Minister of India. So this is either true or false, right? We know that Jawaharlal Nehru is the first Prime Minister of India. So this is the truth value of this sentence is a true. Next, it rained yesterday. So maybe truth value is either true or false. This whatever sentence or statement is there, if that statement contains a truth value either true or false, then we can say that the given sentence or statement is a proposition. So again, example is if x is an integer, then x square is also a positive integer. So this is also truth value is true. Again, the following statement are not propositions. Please report at 11 a.m. sharp. So whatever this sentence doesn't contain any truth value, either true or false. Right? What is your name? So what is your name? So what is the truth value of this? So there is no truth value, is either true or false, right? So there is again x square equal to 30. So these statements are not the proposition because this doesn't contain any kind of a truth value, either true or false. Then propositional variables. Lower cases letters starting from P onwards are used to represent the propositions. For example, P, India is in Asia, and Q is a statement that is 2 plus 2 is equal to 4. So statements or propositional variables can be combined by means of logical connectives to form a single statement called compound statements. So there are different logical connectives are there. Using that logical connectives, we can combine a different statement into a single statement. This is called as a compound statement. So there are five logical connectives are there. There is and, or, not, implies, right? There is, you can say if, then, or if and only if, right? It's also called as a biconditional, or this implies or implication is also called as a conditional. Right? So these are the different five logical connectives are there. So and these are different symbols of these logical connectives. This is a not, right? Or is also symbol for this one is bar, or we can say this one. Also a symbol for not. This is for symbol for and. This for or. This implies there is one directional arrow, and this is a two directional arrow. This is a biconditional. Okay. So next, the negation. So first logical connectives is negation. So it means the opposite of all original statement. If the P is a statement and negation of P is denoted by negation P, then it is read as it is not the case that P. So P is true, then it is not the case that P, right? If P is not true, then negation P is false and vice versa. If statement P is Paris is in France, then negation of this P is Paris is not in France. So truth table for this is P negation P is F T. For F negation is T, and for T negation is F. Next, conjunction. It means adding of two statements. The conjunction here is AND. It's adding of two statements. If P, Q are two statements, then P and Q is a compound statement denoted by a symbol P and Q and referred as a conjunction of P and Q. The conjunction of P and Q is true only when both P and Q are true. Otherwise, it is false. This is a truth table for this conjunction or this logical connectives. And if these both statement are true, then your compound statement is also true. Otherwise, compound statement is a false. Next, disjunction. It means of two statements, that is P and Q are two statements, then P or Q is a compound statement denoted by P or Q and referred as this disjunction of P and Q. The disjunction of P and Q is a true whenever at least one of two statement is true. It is a false when both P and Q are false. See here, what is your whenever at least one of two statement is true. P and Q is true when at least one of two statement is true. This is true. So any one of statement is the compound statement is true. Again here one of statement is true, then compound statement is true. Again here one of statement is true, then compound statement is also true. And if it is false, then when both P is false and Q is false, then your compound statement is also false. Next, implication. This is called as if then. An implication is the proposition. If P then Q, it is false. If P is true and Q is false, the rest cases are true. It is false if P is true and Q is false. Then rest cases are true. Means if first statement is true and second is false, then compound statement is false. Otherwise it is true. It is true. But whenever both statement is false, then your compound statement is also false. If and only if, that is a biconditional. Right? So the logical connectivity is true when P and Q are same. What? When P and Q are same. That is both are false or both are true. If both are true, then compound statement is true. If both statements are false, then compound statement is true. Otherwise, false. Conditional and biconditional statement. Let P and Q are two statements. If P then Q is a compound statement denoted by, you know the symbol for this, right? This denotation is this one, and referred as a conditional statement or an implication. So the implication, if P then Q is false only when the P is true and Q is false. Otherwise, it is true. In this implication, P is called hypothesis and Q is called a conclusion. This P is called as hypothesis or antecedent and Q is called as conclusion or consequent. For example, following are the conditional statement. If A is equal to B, B is equal to C, then A is equal to C. If I get a money, then I will purchase computer. So variations in conditional statements. So there is a contrapositive, converse and inverse is there. So contrapositive, the proposition, negation Q, right? Negation Q implies negation P. It's called a contrapositive of if P then Q. So that is whenever there is a conditional statement is there, right? If P then Q, then contrapositive for this is, so we have to make first converse. We have to make first converse and then inverse. So converse means what? Proposition, this if Q then P, it's called the converse of this statement. Means an inverse is proposition negation Q, negation is called inverse of this if P then Q. So whenever is a P, if P then Q is there. So whenever the question is find the contrapositive. So for contrapositive, first you have to make it converse. If Q, then P, and then inverse. This is negation of this both. Negation of this both statement. This is your contrapositive. This is contrapositive. Then biconditional statement, if P and Q are two statements, then P if and only if Q is a compound statement denoted as if P if and only if Q and referred as biconditional statement or an equivalence. The equivalence P if and only if Q is true only when both P and Q are true or both P and Q are false. So this is the truth table for this one. What is the principle of duality? Two formulas A and A2 are said to be duals of each other if either one can be obtained from the other by replacing and by or and by or by and also the formula containing true or false. Then we replace T by F and F by T to obtain the dual. Means here for duality we have to replacing and by and or by and. That is whenever there is a truth value is T, then replace with false, right? T by F and F by T. So we stop here.